Hi, good afternoon, everyone. Thank you for joining us on time after lunch. I hope everybody got to eat something. Whenever I meet with a teacher at 1 o'clock, that's the first question I ask was like, did you get a chance to have lunch yet? And I'm sad all the times that the answer is no. So I hope that you all got a chance to eat and take a break for yourself because that's really important. So we have to really get started because we have hands-on things for us to do. Those of you who've seen me present before, you know that I don't like to just talk at you for an hour because that's really boring, nor is it engaging math instruction or good andragogy. So we're going to just dive right in and share some strategies to unlock learners' GED math success. I recently just presented this in person at NIACE at New York's Adult Education Conference. And it went really well in person. So we'll hope to be able to translate it virtually as well. I don't know if Eric introduced me, but I'm Cynthia Bell. I should probably do that from the Literacy Assistance Center. I am Liz Elena's colleague, the presenter that you all just saw right before lunch. And I am our Numeracy and Workforce Development Services Director and subject matter expert. So we're going to dive right in. Here are objectives to identify specific instructional strategies that enhance learner success on the GED math assessment, to deepen understanding of how to integrate those strategies. So I really want to make sure that we get a chance to actually like do it and then reflect on how you can implement it, right? I don't want any of us walking away saying, "Oh, that was great in my mind," and not like, "Here's how I could do that tomorrow." So what I will go ahead and give you this disclaimer. This is not 5 tricks to get your score up on the GED, right? Like if that's what you're looking for, that's not what this is. That's not the kind of math educator I am. These are going to be like specific strategies that you can use that will actually help build the thinking muscle for your learners. Because if they know how to think, they will be successful on this test and beyond this test and any other test that they take. So here's our warm up, right? We're going to do the same but different. So I have 2 images here. You can call the one on the left A and the one on the right B. And I'm just going to give you a moment to think for yourself and to consider how these two things are the same but different. I will clarify, we're not doing a compare and contrast. These two things are, in fact, the same but different. So take a minute without me talking, think about it. Don't put your answer in the chat just yet. Let's give everybody like that space to think for themselves. If you want to write your reasons down, you can. All right. I do see some of you all are still writing. But for time's sake, I'm going to move us to the sharing out portion. But if you are still writing, I would encourage you to go, like, see how many different sames or difference you can come up with. If anybody would like to unmute themselves and give us an answer, or if you want to type what you have in the chat box, you can do that too. Let's see what we can get out of our group today. How are these two things the same but different? So I'll give you a sentence frame too. You can say they are the same because but different because. The numbers are the same, but the operations are different. Okay, I see that in the chat box. Positive and negative? Question mark. Anybody want to unmute and give a explanation? The variables are the same, but in different order. Interesting. They are the same because they graph identically on a graph. One equation be graphed as presented. The other equation has to be solved to graph, but both are similar. It is the same equation of a line. Well, I did say that already. I said they are the same. They are in fact the same. So we've gotten some good answers here. I already like it's it's the teacher in me, just from all the answers that you all gave. I had follow-up questions, so it's taking everything in me to not ask those questions, right? But because this is just our warm-up, it is the same equation of a line. A couple of other answers that we could give, right? Yes, it is in fact the same equation. Yes, the value of y is the same for both equations. Yes, the value of x could be the same for both equations. Notice how I said could be. Um, it is in fact the same line. So they are the same, but different. The reason that they're different is one is in y equals mx plus b, also known as slope intercept form, and the other is in standard form, but they are both linear functions. And they are, in fact, the same graph of the same line. And they both have the same slope, obviously, because they are the same line, right? But they're different because they're in different forms. So hopefully we got ourselves warmed up today. And I've already started with one of the strategies. You just don't know it yet. But we're going to move on to like getting you all more involved in hearing your voice. But before I do that, I will just give a little teaser that this is an instructional routine. What we just did was same but different. And it is actually my second favorite instructional routine. I love to do it. In fact, I presented on it at COABE with science. I did a same but different with science. So those of you who teach all the subjects, same but different is where it's at. I love same but different. It's a good way to get students who are having trouble to see something or notice a pattern of something where they might understand one thing, but they don't understand this other thing, same but different, will really help to unlock that. So if you don't mind, you can scan the QR code or you can click on the link that I'm going to drop in the chat box and respond to my Menti poll for me, please. Because that first question is, what are some challenges or barriers test takers face? Particularly, I'm talking about the GED math test. So let's hear from you all because you all have been educators and practitioners and you've seen you know what the students are facing. So let's hear from you. What are some challenges and barriers that the test takers are facing?
Fear.
Yes. Oh, well, you can actually answer it in the by clicking on the link in the Mentimeter. But yes, you can give it to me verbally because then we'll see like the word cloud of it. And I just realized I'm sharing the one from the New York conference that I did, so I'm gonna stop sharing that and open the right one.
Excuse me, Miss Cynthia.
Yes.
My name is Glenda Wills. I'm working from the school where
Mm-hmm.
I work, the center. However, the computer only let me lock in under the name of Christine Barcelos.
Okay. Say your name one more time because I'm a visual person, so I
Glenda
heard you say it and it left my
G,
brain immediately.
that's right. G-E, so my God, I just finished teaching 4 hours. Glenda Wills,
Gotcha.
Wills.
Gotcha.
Okay,
Okay,
Glenda
Glenda.
Wills. So I just don't know how to get my name officially
I just
registered.
changed it for you,
There
Glenda.
you go. That's fine.
Oh, thank
So
you so
thank
much.
you.
Thank you, Miss Eric.
I see that some of you have already started answering, second guessing themselves, lack of confidence, fear of failure, a real fear of math, right? There's always that one, right? That one's always there. Needing more time. Good point. Reading the directions. Time management on assessment and lack of basic math proficiency. Anything else? I'm noticing some themes here. They don't understand the way it's presented. Okay. Translating words to math, especially maybe for our ELLs, bad habits. Oh, I'm so glad somebody put up the word habit. Anything else? All right. I lost my notes, so I'm gonna have to open that back up when I went to transition over to our Mentimeter. So some of the things that you all addressed, we can actually help deal with those challenges and barriers with the strategies we're going to share, particularly bad habits, fear, anxiety, lack of confidence, especially that one, time management proficiency. Some of the strategies that we're going to share today will actually help us to deal with and tackle some of these challenges and barriers because they tend to be the same, right? The same barriers that your students in New Jersey are having, and the same ones that our students in New York are having, and the same ones that they're having in California and Kentucky and Idaho, right? Around this particular GED subtest. So we're going to get right into the strategies. But first, I want to tell you that the strategies all have to do with instructional routines. So I am going to make sure that you all have access to the slide deck. Eric's going to send them out email, but those of you who want to immediately access it at the end, I have a QR code that you can scan and it will take you to the slides. And the reason I'm pointing that out is because right here, this is a hyperlink. It will take you to the Adult Numeracy Network's website where we've curated a page on instructional routines. And there are, I believe, 34 instructional routines on there. Obviously, we don't have time to go over 34 instructional routines today. But if you want to learn more or see more about them, you can click on that hyperlink. It will take you there. I've already even introduced you to one. We did the same but different. Okay, so what is an instructional routine? They are specific and repeatable designs for learning that support the teacher and the student. And there's a key here. They build crucial mathematical thinking habits. Remember what I said at the beginning? It's a thinking test, right? I've heard the math test described as a vocabulary test, a reading comprehension test, a computation test. It's a thinking test. Most assessments are thinking tests. Before I moved into the field of adult education, I was an SAT prep instructor for a number of years. And that test is the same kind of test as a GED test. It's a reasoning test. It's literally called the quantitative reasoning test. It's a thinking test. The GED is a thinking test. The SAT is a thinking test. The GRE for grad school, it's a thinking test. They're thinking tests. So if we do instructional routines, we can help students build mathematical thinking habits. So that way, when there's a question in front of them on an assessment, while they're already dealing with anxiety and time and all those other things, they can slow down and think their way through the problem, not try to recognize, is this that kind of problem that that teacher said that one time that if I see this kind of question on the GED, I'm supposed to do these steps, right? Like that's a lot harder to deal with and remember than learning how to think in your classroom and then being able to execute and answer questions on an assessment in those kind of environments. So here are three strategies. Remember, I said I was going to use strategies? Here they are. Use instructional routines to do the following three things. So all of these are going to be using instructional routines, but you're going to use instructional routines to do these three things. So here's our first one. Deepen understanding of concepts. Go deeper, not wider. Probably a lot of you already even have that philosophy, which I'd love if you did. And then, yes, I hear all of the things about, well, we don't have enough time. And even as a teacher, sometimes we're like, well, I have to cover. If you ever find yourself saying that, if you ever find yourself saying, well, I have to cover, I'd want to challenge you with asking yourself a question after that. What would happen if I didn't? Right? It's better to go deeper than wider, right? We're not just like throwing everything at the kitchen sink. Well, I didn't get a chance to get to factoring yet. Go deeper instead of wider. So how can you do that? Here's an example of an instructional routine that can help you with that on one of the dreaded F words in the math world. What's the dreaded F word? I saw you mouth it, Amber. You guys could have unmuted yourself. Let's see with the chat. What's
I
the
was just
dreaded F
thinking
word?
fractions. I don't know if that's okay.
Fractions. The two dreaded F words, fractions and functions, right? The two dreaded F words. So here's an instructional routine. Fraction talks. Let's do it. Let's actually do a fraction talk. You all see there's an image here. I'm going to actually model the fraction talk. We're going to do it together, just like we just modeled quickly through the same but different. You have an image here. Take a moment, take in everything that you see around our figure here. Our figure is this thing right here. What are 5 things that you notice? You can write them down again on your paper or you can type them in the chat box, but it's important to give that individual thinking time. What are 5 things that you notice? Nothing is irrelevant. There's one whole and one with parts, 3 different shapes being used, 3 colors, 2 hexagons. Cynthia, why are you asking for 5? I always ask for at least 5, especially when you first start introducing the routines. Remember, we said routines are repeatable, right? So the more you do them, it creates the expectation where the students know exactly what you want them to do, and you know exactly what you're going to get from them, right? A classic one is notice and wonder. Pretty sure all of us have done notice and wonder. I said notice and wonder, and you knew what was about to happen. She's going to ask me to notice something, and then she's going to ask me to wonder about it, right? 1/3 for parts, 3 colors. Got it. All right. So now, after we pay attention and we notice things, you can follow up with different questions. Again, we're virtually, and this is a short time span, so I'm having to condense it. But I would ask questions like, oh, you see 2 hexagons. Could you show me where you see 2 hexagons, right? You can actually have the student come up and draw on it, or maybe you have the picture on a piece of paper. Where do you see the 2 hexagons? Where do you see the 3 different shapes? Oh, you said there's 4 shapes. That's interesting. Can you show me what those 4 shapes are, right? You're really drawing on what they've noticed. Nothing a student says is irrelevant, right? As educators, especially adult educators, it's important for us to value their thinking. Remember, these things are about crucial thinking habits. I value your thinking. If someone says something that I don't agree with, I'm not going to go, well, that's an incorrect observation. That's something that they saw. In fact, the first time, actually the third time I did this with some students, I had a student said that they thought the one on the left was a cube. And I was like, what? And then I realized it was their perspective, right? Like I'm looking at it down like this. And now, unfortunately, I can't unsee that bloody cube on the left-hand side, right? Some of you are nodding. You're saying you're nodding, but I didn't see anybody drop in the comment section that they saw a cube. It's the first thing. Well, you didn't say that, Eric. Okay, right? Like you, what you see matters. All right. So take in what they see, what they notice. Maybe they do a turn and talk with a partner. Maybe you start out with like 3 things that you notice individually, and then they turn and talk with a partner and find 5 things. Because I was the person who didn't see the cube, but if you put me with a person who does see a cube, now I see the cube and now I see other things, right? So you can turn and talk with a partner. Obviously, it's a fraction talk. So now that I've gotten you to pay attention to some of the things, I am going to ask you what fraction of this figure is green. You can drop it in the chat or you can write it down on your paper. This is a safe space. And if I was doing this in person, I like to have like individual whiteboards when I had a classroom, and I would have my students to write their answers on the whiteboard and go like this, right? So that I can see everybody's answer, but also that they're not necessarily calling out, because sometimes students will hear 1 or 2 people say an answer and then they'll shut down because they'll think, well, the teacher already heard the answer they wanted to hear, or my answer is different than what everybody else said, right? So that's why I like the little whiteboards, so that way everybody gets a chance to respond. And I'd say, I see you, I see your answer, I see you, I see your answer, I see you. Or maybe you even do like a Mentimeter poll where everybody just writes their answer, submits their answer via Menti. However you want to go about doing it, but I want to make sure that I respect that everybody gets a chance to answer when I run a fraction talk. So I'm saying one third, one half, two fourths, one half, one sixth, two thirds, one half, one half, one third, one sixth of the entire thing. Okay, remember we said this is about deepening concepts? Well, one, I like to use instructional routines for formative assessment too. Instead of giving my students a worksheet at the beginning to see where they are in their understanding of fractions, I do a fraction talk because that lets me know right there who has a deep understanding of what fractions are and who doesn't. Um, and then now I can build out from there. The students who gave me that it is, especially I get this answer a lot more than I wish that I did. One, two, three, four, right? That there are five objects and that there's two green pieces that are green. So two-fifths. That lets me know that we need to deepen their understanding about what fractions are. Fractions are part of a whole, right? What they did was give me a ratio. They gave me a ratio of two pieces that are green out of six pieces. That's a part to part ratio. It's not a fraction. A fraction is part of a whole, right? But I could now ask, okay, well, what do we know about fractions? We can have a conversation about fractions. And inevitably, what I find when I do the fraction talk is that there's a lack of understanding about the whole having to be broken into equal size pieces. The whole has to be broken into equal size pieces. I see your hand. One moment, Glenda. So I do the fraction talks and I do them over and over and over until we can get an understanding that fractions are a part of a whole, but the whole has to be broken into equal sized pieces. And that is why we have common denominators, right? Now I can start to even build more on that understanding. Common denominators, in order for me to be able to compare fractions, in order for me to be able to add and subtract fractions, which are combining like terms, I have to have common denominators. The whole has to be broken into equal sized pieces. A fraction talk will let me deepen their understanding about them. And the more you do them, the more the students will get that. Because you can just say it has to be part of a whole. In fact, I'm sure all of us have said it. And then the next week, you can do another fraction talk and you'll still get people who just count them. And I know that because that's what happened to me, right? Here's some student work. And I do see your hand. I'm going to get to you in a second, Glenda. This student originally said it was 2 out of 5. And then they started, you can see they actually started drawing, right? I asked some questions. I started to ask them, I went back to what they noticed. That's why it's important what they noticed. I noticed in their noticing list that they noticed that it was two green triangles and that they looked the same as that blue piece. So I went back to their list and I pointed that out. And I said, well, if you think that the green triangles look the same as the blue piece, what would happen if like you move those over there? And as soon as I said that, the student was like, oh, and they started like drawing all of these. This is actual student work, right? Then you see that they started trying to do a little bit of math here, and then they're like, wait, no, right? So they're thinking through what makes sense about their understanding with the fractions. Here's another student. Same thing. This was a student who saw the cube. You can even see like how they drew it. They're like, this is a cube. And then they tried to draw that cube on the yellow one, but they still were coming from a place of it's part of a whole and the whole has to be broken into equal pieces. So they were trying to actually now break up the equal size pieces. And then they eventually got it. But that was week one. I did it again, right? I did it again. And I'm not gonna lie, the next time I did it again, they did the same thing. They counted the pieces and they're like, it's 1 out of 10. And I'm like, I thought you had it. But what do we say our strategy is? Go deeper. So I did these fraction talks over and over and over and over. So I'm going to pause right there to hear Glenda's question, and then I'm going to tell you about strategy 1A because it still is connected to our fraction talks. Go ahead, Glenda.
Yep. Thank you very much for that last one because I kept seeing an invisible cube on the yellow.
And so did that student, right?
And when I
So did that
saw that, I
student.
said, that's it. Somebody thinks like I do.
So did that student. And those of you who have manipulatives in your classroom, totally do them, right? Like use them, right? So the
Thank
step,
you.
like 1A that I have for that is to help students connect or anchor to something they already know or understand. You probably already do this. So I was really struggling as the teacher to still really get them to understand this concept of part of the whole, but the whole has to be broken into equal sized pieces, right? Like they did it on the last one. You saw them do it. They eventually got the answer. And then when I did it again the next week, I still got, there are 1, 2, 3, 4, 5, 6, 7, right? I'm like, ah. So then I had to employ my other strategy, connect to something they know and understand. So this is what I did. I took out a lasagna. I was like, you have a lasagna, you're like your mom made a lasagna, you love lasagna. It's like your favorite thing to cook, right? Okay, you and your three siblings or you and your three friends are over the house and your mom says, "You got to share out the lasagna, make sure that everybody gets a piece." And this is actual student work, right? That's why the person's name is there, but you guys don't know who Lily is. It's fine. I was like, make sure that everybody gets a piece. And I drew that line. I said, Lily, if I cut the lasagna down the middle like that and say, this is your piece, how do you make sure everybody else gets another piece? So she drew these other two pieces in there. And as she was drawing them, she was like, but wait, no, I don't like that. And I said, tell me, why don't you like that? She said, "Well, because." I'm like, "Because what? Why don't you like that?" Right? Like there's a something going on in her head. Why don't you like that? She goes, "I don't like that because everybody else doesn't get the same size piece." Oh, really? Right? A fraction is part of a whole where the whole has to be broken into equal sized pieces. So now we did another one. And this is Lily's work. As you can see, each question, each one gets progressively more and more challenging. This time, the first thing Lily did was say, I noticed that the green has green triangles and that purple is the same shape as the green one. And so I could break the purple into the green one. Like she immediately went after making these equal sized pieces. She didn't even know what question I was about to ask, but she still was like, I know that I got to have equal sized pieces. And as you can see, now I even took it to percentages, right? So we can go deeper and deeper and deeper with our concepts with these instructional routines. So eventually I did ask her like what fraction of the shape is green, but then I went with like what percentage. Actually, that was the question. I asked her what percentage of the shape was green because I wanted to see could she translate her thinking now. And there was like a control alt delete moment for her. What why are you talking about percents? I'm good with fractions, right? But then we had to build our understanding that fractions and percentages all represent the same quantity. They're just different forms of that representation, such as decimals, fractions, and percentages. Eventually, she was able to make that jump. This is her work. And then another question I asked her was what fraction was blue, right? Like now I'm really going after her understanding every time after that I did the fraction talks, no matter what kind of fractions I asked them, no matter what kind of shapes that I got them, I didn't have any more students just counting and giving me a ratio. Everybody knew I got to have part of a whole. And no, in case you're wondering, well, were they always little triangles? No, sometimes I threw trapezoids at them, right? Sometimes I threw trapezoids at them. Sometimes I threw really complex tessellations at them. Either way, they knew that they were going to have part of a whole, and that whole had to be broken into the same number of pieces. So I'm going to pause there for any thoughts or questions or comments about how a fraction talk would run.
Folks can unmute themselves.
Has anybody run a fraction talk before? I see her raising hands. I mean, some people nodded at me. I kind of glossed over that part, so I want to make sure that I bring attention back to it. When you're running a fraction talk, you really want to take the students' work, the students' answers, right? Notice how I said I went back to their notice page. When I get the student fraction answers like that, I'm always going to write them down on my chart paper. I heard you say 1/3. Okay, let's talk about how you got 1/3. Could you share with the class how you got 1/3? That's why it's called a fraction talk, right? You got 1/6. Could you show us how you got 1/6? Right? Our job is just to facilitate the conversation to get them to the point where they are now deepening their understanding about fractions.
Cynthia, I think, one of the things that you mentioned earlier was formative assessments. And I think those talks will help you understand how well the students comprehend the concepts and the terminology, right, as they're walking you through it. And, there'll be times where like they get the concept, but they don't know the word for it or vice versa, right? And you can be like, oh, yes, this is what we call this, or this is what this means.
100%. In fact, I try to, that's part of our routine, lay that foundation down there that like, don't get stuck on whether or not you know the math term for it. In fact, I used that exact word. I was like, I don't need you to give me some deep mathematical, philosophical reason that's going to change my society and world, right? Like, just tell me what you see, right? Because sometimes they're like, well, I see this, but I know that's not what you want me to see or what you want me to say. No, I want you to say whatever you saw, right? Like, I don't want you to say, well, the vertexes of the right? Like, I can tell you that it's a vertex. I can tell you it's a hexagon, like you said, right? Now we get a chance to build vocabulary. This is the other reason I like instructional routines, especially talks. So we have number talks and fraction talks, but I wanted to model the fraction talk simply because of that dreaded F word, go deeper instead of wider. I personally think that we should not be teaching percentages and decimals and adding and subtracting fractions while people still have a fragile understanding that a fraction is part of a whole. And the whole has to be equal sized pieces. And the numerator tells me how many of those pieces I have, along with, and I said this at the NIAS conference, and I literally had somebody come ask me afterwards, why do you not? So I'm going to say it. I don't like calling them improper fractions. I know our elementary teachers, we probably say it, they're not improper. What's improper about it? There's nothing improper about it. It is simply a fraction where I have more pieces than the whole. I need my students to understand that. That means I have more than one. My lasagna, that means I've got more than one lasagna that I get to share out, right? Like, so that's just like a small, please, can we stop calling them improper fractions? Because it does something to our students where they feel like, I'm not allowed to have that. My fourth grade teacher said, I'm not allowed to have that. I have to change that. Why? 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 And then they struggle with understanding 150%, which is more than the whole. Who are you calling irrational night, right? I literally had a teacher come up to me afterwards. He's like, okay, I'm gonna need you to give me more information about why you don't like improper fractions. He's like, because they do exist. I'm like, no, they don't. What exists is fractions where you have more than one. I was like, somebody someday just decided to call it improper, and there's nothing improper about it. It's just a fraction that I have more than the whole. He's like, ah, okay, 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 right? All right, next one. So we just did strategy one, go deeper instead of wider. And I gave you like strategy 1.5 of like connect while you're trying to go deeper instead of wider, while you're trying to deepen concepts, connect to something they already know. That is brain science 101, right? We have to trigger the thing in our brain that we already know. They call it, you have to fire it to wire it, right? I have to fire or stimulate that thing that you already have an understanding of or connected to then wire to another new like neural center that you're trying to form, right? So connect to something they already know or understand. It was the lasagna thing that really helped the student understand it, right? Like as soon as they said, oh, then they were like good to go. All right. Strategy number 2. Oh, time, help us, Lord. Okay. Strengthen learners' ability to look for and use structure. I love this one. The whole test is about understanding and recognizing that there is structure. And I don't just mean structure to the test, but like structure in math. What do you mean by that? I'll give you a digital literacy example because we've been focusing on digital literacy a lot in New York City with our peer learning community. If you're struggling like navigating a new platform, but you have the skill of looking for and making use of structure, even if you're on a new platform you've never been to before, you will apply the structure that you already know and understand to that new platform, such as like if you know that you have 3 horizontal lines, the structure that you understand about that is that tends to be a menu. So even if you're on a new platform you've never seen before and you click that, you expect to click that and see a menu because you have looked for and you understood structure. There's structure just like that in math. So let's do an instructional routine for that. And that is instructional routine I like to do when I want to strengthen students' ability to look for and use structure is called What Do You See? Here's that routine. It's called What Do You See? Cynthia, that sounds a lot like notice and wonder. You're right. Like a lot of math is about noticing patterns and noticing structure. So take a second. You see the graph there? What are 5 things you notice about the graph? I know some of you are thinking, she's been making me do a lot of math for the last 20 minutes. Ah, you're the second person, Amber, that noticed an arrow. I never saw an arrow before either, but someone recently said I see an arrow. But that's not 5 things. That's only one. Give me 5 things. Maybe you wrote it on your paper. Give me 5 things you notice. I see a sword. Interesting. What else? Connect the dots. Age, heights. Ooh. Dots are in descending order with exception of 1 and 5. Again, you can do the same thing, turn and talk with a partner if you'd like. But what do you see is really important. And the reason that I really do the what do you see is because a lot of students just jump in and do things with numbers, especially with chart tables and graphs. Some of you have probably done a slow reveal. That's a good instructional routine to help people to stop and take in the information as well. But regarding looking for structure, I like to do what do you see? Because you're forcing your brain to pay attention to things and look for structure. Now let's see if we can use it. We're actually going to do this activity. Here you go. Ready? Using the graph, I only have time to give you about a minute and a half, so I apologize for that. Using the graph, identify who's represented by which point. What do you mean by that? I mean, Alice, is she number 7? Is she number 3? Is she number 5? Tanya, I don't know if you meant to put hashtag ampersand. There you go. It's like
He's a
Gavin is
sig
hashtag ampersand.
he's a Sigma. He's off the chart.
That's why I need to stop typing and just speak.
Ooh, I even like people who are like, oh, it's 1 or 2, right? You were looking for structure. Alice is 1. I really like this graph along with another one called taking a bath. What do we say we want them to do? We're going to use instructional routines to help students build the habit of looking for and making use of structure. Okay, just because of time's sake, I'm going to move us on. Hopefully, some people may have noticed, and even if you didn't, that's fine. But hopefully some of us noticed that we saw age here. And again, I run this like a number talk. So if I'm hearing someone say, oh, I see age, I'm going to ask questions like, oh, okay, you see age. What is that age? Where is that age? Oh, it's here, right? Maybe they don't know to call it the y-axis. Most they maybe could describe it as vertical. Now I can say, oh, that vertical thing right there, that's called the y-axis, right? The y-axis is vertical. And so you notice that age is on the y-axis. That's interesting, right? You notice height is down here. You might even literally have students say that. I notice height is down here. Great. Height is down there. Is that what direction do you think that's going in, right? Like I try not to say vertical and horizontal. I want to get them to be able to use those words. Oh, it's horizontal. So we call that the x-axis. So what we notice is that height is on the x-axis and age is on the y-axis. Okay, right? So with each one of their notices, that's why we call what do you see? Because in my experience, when I started to do this graph, before I would do what do you see, a lot of people would mislabel what they are because they're not paying attention to the relationship between the height and the age. Also, if I notice things first, such as that there's a horizontal line that goes between 4 and 5 and 1 and 2, I've noticed structure. And that structure, if I get a student says that, I'm like, yes, now I can pick up that. Huh, that's interesting. What does that horizontal line mean? That student or anyone else, now we can talk about what does that mean? Well, that means that they are the same height. Is that what that means? Well, no, wait, hold on a second. That means they're the same age. Well, is that what that means, right? Like, I need them to know it and understand the structure. Okay, wait, so we eventually get that they're the same age. So, wait a minute. Like, I love it when a student says, wait. That I'm like, that means they're cooking, right? That means they're cooking. Wait. That means wait. That means these two people are the same age. That's interesting. Did you see two people over here that were the same age? What do we say this routine is called? What do you see? Notice how almost every question I ask is about, did you see? Right? Because I'm trying to help deepen their ability to look for and use structure. So first they looked for structure here, now they use it. That's how we can help them to start to correctly identify it. It's rare that I've had students get them all right on the first try. But what I do need to have them do is go back to what they saw and make sense of what they see. That's a test taking skill, right? We said this is about how do I increase my score in the GED. So I need to teach them how to make sense of what they see. Okay, once they start to figure that out, and just like our comment section, most people immediately go, Gavin's number 7, right? But then I ask that question, well, how do you know that? Right? I'm listening for, oh, they're the person that's the youngest and they're the person that's the height. But I'm also listening to see if anybody might talk about this as being the origin, right? That's my bad handwriting, right? And now I can even make a connection. I'm like, well, Gavin is an infant, which means he's closest to the origin in which he just came from, right? That's the origin of our graph. The origin is where the X and Y axis, right? Like think about all the things now you can deepen. So there goes our strategy for the first one. You can deepen understanding of from a place of doing a routine such as what do you see? Kind of pause there. If you're waiting for me to give you the correct answer, you're going to be waiting a long time because I'd rather for you to reason and use your structure. Because if you reason and use your structure, you'll know whether or not you have all of the right answers. I will point out one more structure. There's another structure here. We got vertical lines. Oh. And I was teaching the concepts of functions just yesterday. And I went back to this graph. My students had already done it. And I went back to this graph and was like, remember this graph and how we saw these vertical lines? What do those vertical lines mean? Oh, they're the same height. So is this a function? No, no, it is not. There's a relationship between height and age, but it is not a function. So I actually connected our understanding of what functions are back to something we had already done. Any questions or comments about how to do a what do you see? You could even layer it into other routines, but what do you see is literally just that. Give them part of the thing, force them to pay attention to what do they see, and now take what they saw and give them the opportunity to use structure with what they saw. Hence, look for and make use of structure. Questions, thoughts? What would happen if? Okay, well, somebody gave me a thought. This is interesting. I like that. That means you're thinking about it. I've done my job if I at least gave you something to think about. All right. Oh, time. Okay. It's like choosing between three children and which one's your favorite. I love all of these strategies. Like each one I want to be like, this is my favorite, but wait, no, the other one's my favorite. Okay. All right. Because all of these things, the reason why I value them, they're all going to help a student who needs to pass this math test, right? You've got a student that just needs 5 more points. They don't need another trick. What they need is for you to teach them how to think. So here's strategy number 3. Use instructional routines to stop and make sense of a problem before jumping in to do things with numbers and keywords. Oh, I know that might hurt. I'm sorry. I'm sorry. If you have that poster of keywords in your classroom, cool, cool. And maybe, right, we could try something different because keywords don't necessarily help a student to assess for reasonableness, and they can be easily tricked without making sense of the question. Here's a classic example. This problem here. I see a keyword. I remember this. Miss, I'm just going to call a name that I see on my screen. Miss Amber. She taught us difference means subtract. I see 32 and 5. Subtract. Boom. 27. Booyaka. Wait. But there's the word 15 in there. What am I supposed to do with that? Nah. Miss Amber said difference means subtract. I see numbers. Subtract. The answer is B. Hold on a second. Wait, was there any reasoning that happened at all in this question? Like, I also see this one of the questions about the number of people you need for something, and the answer they gave is like something like 4.6, right? Like, we gotta help them to stop and make sense of the problem and not just jump in and do things with numbers and keywords. If a student actually tried to make sense of this problem, they would know that the answer 27 doesn't make any sense. Okay. Okay, Cynthia, you got the pain point, right? But what's the instructional routine? How do you help that? Right? Like we all have that student. You're probably thinking about that student right now. What's the instructional routine? I got you. Here's the instructional routine for it. See, think, and question. And I'm actually going to layer it with another routine called slow reveal. So I'm going to have to come out of our slideshow so that I can slowly reveal it to you. So we're going to do it, but we'll have to do it quickly because it's 1:51. Okay, so I'm going to come out of a slideshow. Hopefully you can see it and make it as big as possible. Let's see if I can make it better. Okay. See, think, and question. So how does see, think, and question work? You give them more than likely a word problem. Sometimes I do it with an equation. Word problem, and you ask them to stop, because that's what the strategy is, to stop and think, right? To stop and tell me 3 things you see, 5 things you see, whatever, 2 things you see. Then what do you think? This one will take some practice as far as getting them to understand how it works, because this is what's actually happening in their brain and they don't realize that's what's happening, right? A lot of times we as people do that. You see something and you immediately think about it. And so a lot of times they label the thing that they thought as the thing that they saw, right? But actually it's like, I saw this and I thought that, right? Like I saw the number 27 and so I thought I should subtract, right? Like those 2 things are separate. So you want them to see, you want them to think, and then you want them to question. You can even give sentence frames. I noticed that, I thought that, and then for question, I wonder what, I wonder why, I wonder if. I wonder what, I wonder why, I wonder if. Okay, let's do this expeditiously. And the reason I said slow reveal is because I know that sometimes it helps scaffolding to do a piece at a time because I really, really, really want them to stop, see, think, and question. So let's do it. Here's the first part. Janice buys a shirt that is on sale for 25% off of its original price. Give me one thing you see, one thing you think, one question you have. I am going to have to move us along. Next part, I would reveal the next part. When she brings it to the counter, she opens a store credit. One thing you see, one thing you thought, what's a question you have?
So Amber had noticed the 25% off in the first sentence.
Got it. Thank you. Then we do the next part. This earns her an additional 10% off the discounted price. What do you see? What do you think? Oh, I lost my internet. Uh-oh. Can you guys still hear me?
I think they've sucked her in. That's what I think, that they're getting
Uh,
her to buy the store
Credit
credit.
card. And then here's the last part. I'm just going to delete it. What percent off the original price is the new cost of the shirt? That's the reason I slow reveal this. You don't have to slow reveal a see-think question. You can just give them the whole problem, but that's the reason, because this is a classic percentage problem that 98% of my students would get wrong, because they would add 25% and 10% together, say it's 35% off, and go, booyaka. And I'm like, okay, right? So let's pay attention to each part of the problem. I actually have student work for us to look at. That's why I wanted to get there. I'm sorry that we didn't get a chance to actually engage in it more ourselves. But here's some student work. And I slow revealed it with her, with the student. You noticed that she says she noticed Janice wants to buy a shirt. Shirt is 25% off, 10% off. Every time I've done this problem with students, every time, what they see is 25% off and 10% off. I have yet to have one student say that they saw 25% off the original price. And that matters, right? Like, because that's where they're about to get got, right? Like, it's like, because none of them are paying attention to that. And then even when we go into the think, none of them are thinking about the original price, and none of them are thinking about the discounted price. Look at the questions here. This student did not think about that at all. Do you think this student got the question right? I mean, got the answer right? Maybe, yes, no, yes, she thought it through. Unfortunately, she didn't, right? Just from looking at her see think question, I knew she was going to get it wrong, because she didn't pay attention to the original price. She didn't pay attention to the discounted price, right? So now you see the highlighted. This is us now going back after the first attempt, right? And even right here, this question right here, I love that they were thinking about it. What does the new cost of the shirt mean? When that student wrote that, I went the same thing. I was like, that's a really good question, right? Stop and think about what this means. So we did the see think question again. And that's now when the student was paying attention to original price, discounted price. I would love to say that I did get to have a student that did this routine and got it right on the first try. And this is a classic one. I'm sure we've all seen problems like this, right? With the percentage. And if you look at the multiple choice answers, the one where they just do 35%, then you might also get some that are stuck, right? A lot of times I'll get the question of like, well, how much does the shirt cost? Well, I can't do anything because you didn't tell me how much the shirt costs, right? That shows me that there's a lack of flexibility in their thinking and understanding about percentages. Does it matter how much the shirt cost? No, because the percentage will be the same, because the question is what percent off, not how much money did they save, right? There's a lot of mathematical thinking going on in this question. Even if you have ELLs, this is another good way to help them to process all of the words in it. So see thinking question is a way to do this third strategy of getting the students to use instructional routines to get students to stop and think about what makes sense before just jumping in to do things with numbers. The more that you do this routine, the more that they will build that thinking habit, right? It's a habit that they will start to build, and it will get easier and easier. And now when they go to take that test, they're going to immediately start to do those things. I noticed that. I see this. Okay, I wonder what I'm supposed to do with this. And then they'll plan a solution pathway and be able to execute it. So let's reflect because we got 1 minute and I really want to give you all a chance to think about. We shared 4 instruction routines today. Same but different. What do you see? See, think, and question. And what was number 1? I forgot that fast. Pop quiz. What was number 1? Same but different. What was number 1? I forgot. Which of our strategies will you aim to focus on most in your instruction this week? Like, which one are you like, I'm going to try that this week? Same but different. See, think, questions. What do you see? And I still can't remember what the first one was that we did. What do you see was the second one? Oh, fraction talks. And then what small change could you make today to implement your children's strategy? Maybe you want to focus on deepening understanding. Maybe you want to focus on helping students to look for and use structure. Or maybe you want to focus on getting them to stop and think about what is there before they just jump in and do things with numbers. I like it. I would do fraction talks. Because that's all right. Because that's why I'm going to make sure you have the slides because we did kind of rush through the last one. I really have been getting down with see, think, and question more lately.
I mean, I think, Cynthia, the point that you made at the top of the hour, right, which is that this idea of I have to cover this stuff, right, and that's not the same as either teaching or learning, right, and so just rushing through things and talking about it doesn't mean students are going to walk away with understanding of it, right, and so spending more time, understanding what the problem is, understanding what the question is, understanding what the concepts are, that's the only way they're going to learn what this stuff is.
And really, truly be successful past the GED, right? Like your student wants their GED, and then what? Right? Like, what are they planning on doing with that GED? They'll still need these thinking habits. That's why we set routines, build crucial thinking habits. We're teaching people how to think so that they can achieve the goals that they have for themselves and their family and their communities and not have barriers placed in front of them and where they need someone to tell them specific steps to do certain things, right? They're like, no, I can figure this out because Miss Michelle was my teacher, because Miss Rebecca was my teacher, because Eric was my teacher, because Miss Glinda was my teacher, right? So I hope this was helpful. I gave you the QR code for the slides. If you want to steal that graph question, go ahead and steal it, right? I built it on Canva. Go ahead and steal it. It's a classic problem called the bus stop queue. Like you literally Google it, but you can steal that one. I made it so you can use it, right? I hope this was helpful. And thank you, Eric, for inviting me back to NJALL this year. And I'll stick around for like 2 minutes. I don't know. You probably have something else if anybody has any questions.